Hi, everybody. I'm going to assume that you're comfortable with um, our digits place value and expanded form in base 10, but I do want to do a quick little review of this before we go and look at place value and expanded form of other bases, because if we can do base 10, we just have to do a little bit of mental manipulation to be able to use the other ones. And we do use other ones every day. We use base 7 when we're talking about days of the week. We use base 12 and 24 for the hours of the day. So there are all sorts of ones out there that we use. So it's good to be comfortable with them, even if you're not in computers, and computers use even more. So let's take a look and just focus on what are we doing. So when we're in base 10 and place value, we have our decimals. So the ones below a whole number, tens, tenths, and hundredths, they're 10 to the negative 1, 10 to the negative 2 power, or the fraction 1/10, 1 over 100, or 0.1 or 0.01. So anytime we have something with a decimal, that's what it would look like. We won't be looking at those in detail for our other bases just because it's not as intuitive as the rest of it. So if you don't think the rest of it's intuitive, you can imagine what the fractional portions would be. So we're going to focus on our whole numbers. So when we're dealing with powers of 10 and place values, we're looking at the ones column, the tens column, the hundreds column, the thousands column, could be way more, tens, thousands, millions, etc. So what do these mean? Well, it's just the different powers of 10 that we have. So 10 to the 0, anything to the 0 power is 1. And so that's why we call that the ones column. Tens place value is 10 to the first power. The hundreds is when we have 10 squared. Notice it's 100. And 10 cubed is the third place, third 0. Not exactly the third place, but the third 0 after the 1. So that's thousands. Now, we don't actually have these nice names for them in our other number systems, but it's okay to think of them that way. So if we had the number 473, what we could do is put 1 in each column. In the appropriate column, 473. And we notice that 4 lands in the hundreds, so that could be written as 4 times 100 or 4 times 10 squared. 7 could be written as 7 times 10 or 10 to the first power. And 3 would be written as 3 times 1 or, depending on what you're doing, times 10 to the 0 power. Either way works. I just happen to like writing it this way when we're writing an expanded form. So we could use either row for noting our expanded form. We could also do decimals, but like I said, I'm not going to do that. So let's look at another one just for a quick review. So say we had 3,269. Notice our digits though. Remember in base 10, we have the digits 0, 1, 2, 3, 4. We don't have a digit for 10. And that's okay. Because what is our 10? It is over here. It's a 1 followed by a 0. Because we're in the tens place to the first power. Okay, so we have our value to the first power is right here in the tens place. So this is 3,260 9. So again, it's just 3 times 10 cubed, 2 times 10 squared, 6 times 10 to the first, and 9 times 10 to the 0. So hopefully that little review helps you with our place values for base 10. And let's take a look at place values for other bases. So if we're looking at base 5, before we even look at expanding them or anything, remember we don't have a symbol for our base. So here we are going to use just the digits up to but not including our base. So 0, 1, 2, 3, and 4 are the only digits we can use when we're working in base 5. So we cannot have 526. It doesn't exist in base 5. So what good is it? Well, we've got other reasons why it's good. So don't worry about that part here. Let's worry about understanding how we're going to look at it. So if we have a base 5 number, say we have 423, nice base 5 number. So in the hundreds column, we're going to put a 4, a 2, and then a 3. So this would be 4 times 5 squared, because that's the column we're in. 2 times 5 to the first, 3 times 5 to the 0. Now, when we write it out in expanded form, we're actually going to usually put a plus sign in between. So next, we're going to do one more. Say it's, I should always write the base next to it. So if it's 3, 0, 1, 2, 4, base 5, it might be easiest actually to start at the ones column. So we're going to start by putting in our 4, and then our 2, and we just fill in each spot. Now that we're at the 10,000s column, we know we have 3 times 5 to the 4th, 0 times 5 cubed, 1 times 5 squared, 2 times 5 to the first, and 4 times 5 to the 0. And again, we're just working on expanding at the moment. Another video I will go on and convert it back and forth between the different types. Okay, so let's look at expanding a base 16. This is a very common one, and I forgot to fill that in. Goodness me. So let me quickly fill this in. So we have, okay, now that this is filled in, let's just do the same thing. We'll expand a base 16 number. I think we're just going to do 1 right now. So if we have, digits. What are our digits? Base 16. That means we need a tens digit, 11, 12, 13, 14, and 15. So what we do, since we actually run out of digits after 9, 2, 3, 4, 5, 6, 7, 8, 9, they use the regular alphabet. Now, if we were to go beyond the 26 letters, which could happen depending on your system, you're going to use something else. So A, B, C, D, so that's 10, 11, 12, 13, 14, and 15. Remember, we don't need 16 because when we hit 16, we go to the next column. So we have, say we have 4, 5, 2, 8. So we have 4,528 in base 16. So again, it might be easiest to start in the ones column. and fill it in going to the left so we can keep track of where we are. So this would be 4 times 16 cubed, and let's see, 5 times 16 squared, 2 times 16 to the first, 8 times 16 to the 0. So that's all we're doing for expanded form. Now, if we were to convert this, you would see that this is a really big number compared to what it would be in base 10. So this is actually a convenient way to write larger numbers. It takes up fewer digits. But this isn't the way we're used to working. We're used to working with base 10. However, computers work in base 2. They have a switch and it tells it if it's on or off. And then 16 is actually a power of 2, as you'll see on the next slide. And so working in base 16 is helpful because then you can group together a whole bunch of base 2 items. So let's go over base 2. So base 2, again, here, however, it's called binary because we have 2 options. It's on or off, 0 or 1. So in binary, we have the digits 0 and 1, and that's it. So if we want to write a number that's in base 2, the only way we can write it is with zeros and ones. And we don't usually write leading zeros, but in some applications in computers, you need to. So just keep that in mind. So I'm going to do 1, 0, 1, 1, 0. So again, just to make it easier, this is base 2. 0, 1, 1, 0, 1. So this is 1 times 2 to the 14th. No, not 2 to the 14th, 2 to the 4th. 0 times 2 cubed, 1 times 2 squared, 1 times 2 to the 1, and 0 times 2 to the 0. And that's all we're doing for expanded form. So I hope this helps you with the place values and expanding our other bases so that we can then have an easier time converting them.